Everything you're doing here is stupid and I'm participating anymore. I'm stopping out.
Yeah, so if there
Probably didn't go far enough. Probably stopped at This room is not laid out properly. Well, we had an opportunity to put the screen behind the pillar.
But you can move, backwards. Just move under the chair behind the pillar.
So it's okay.
And you can move yourself back there.
Wait, you put your light behind the pillar?
No, we should have moved the screen behind the pillar.
Right, yeah.
Yeah.
The light behind that.
And the light behind that pillar.
Did we do that one year?
But that was
No,
in the room like that.
Oh, yeah.
Broad room had pillars in the middle.
It's a tradition in this group.
Double blind question and answer?
Yes, exactly. It's academic peer review.
Oh, absolutely.
Of course, actually came up to me how they tried harder. So,
I will show this now.
Oh, wow.
that's a nice picture. I saw that already, Tara.
Yeah, I know. It's just one of the reasons why the IPSECME progress has been a little bit slow last month.
Well, I didn't know where you'd taken it until you told us that you returned from some. I didn't know. I saw the picture you posted on Facebook or something, and then
In Chile?
sometime later, I learned that you actually had traveled to get this picture.
Yeah.
I would have written some Python in Blender.
I use GIMP.
Yep, but whatever.
So it's GIMP,
Okay.
because it's a GIMP.
GIMP used Python as well.
Nobody uses the new stuff. The scheme has
You
been.
don't save your files in XCF. It warns you every time before you quit.
I know, you should save it in XCF. I'm like, no, I really want PNG.
It's up to the point where I really like to talk about this extra.
I'm not gonna-
Patch for GIMP.
To do that, yes, that would be nice. Thank you, Paul. That would be nice. Okay, so I'm going to take notes that.
The reason I'm not going to be opening this because it takes about 5 minutes to open it in GIMP. It's 700 megabytes compressed, and it expands about 5 gigabytes.
So it's a series of stills taken with a timer.
Every 5-minute interval, one sun, and then
On a
during the
tripod.
totality, remove the filters, take the, especially for the total and the background. And it of course ends in the sunset. Let's move to
Data tracker took too long to respond.
Yes. I'll check.
All right, so we are.
Why can't I get everyone to write down? We're a little behind on that.
All right, so let's start then. This is IPSECME, IPSEC minors and minor extensions. I think we have a minor though, shouldn't we? Oh, it's only exam. Yeah. All right, so this is the notebook. You probably noted already. And Blue sheets, yes, let's put that on.
Momentary.
Yeah, so we need usage, we need we need volunteers to take notes. Michael was one, do we need to get another one? We are using Etherpad to take notes. So it would be useful to have somebody else because Michael usually runs to the mic at some point. If not, I can try to do something also. Do we need the jumper scribe? Somebody good? Okay, thanks. You're already sitting in the place. All right.
Describe anything in the previous section.
All right. So that's the start. All right. So here's our agenda. Do we have anything that people want to change? We have a status report. We have items. We have other presenters. We are going to have a very short, announcement in the actually before the working group status report. And now so nobody will have any.
Sorry, it took me a while to find the microphone. It's a little. Maybe it's not a wireless one either, so I can't take it to the middle of the room. No. So all the speakers have to be here. Okay. Hi, I'm Paul Autos. I just wanted for agenda bashing. Everybody seemed to have forgotten about the graveyard draft, and maybe we should spend 1 minute on that and see what we want to do.
No, we did remember it, but we realized also that if the authors doesn't push it, we are not going to be pulling it.
Oh no, okay. So we're ready for working group adoption.
So I think that one Bluetooth is going to be enough. So we just go it back and forth. So such a small group is easier to count if you have only one. All right. So yes, the graveyard stuff. If I think there was supposed to be starting some discussion in the working group in the mailing list, and there's a couple of other drafts that was same thing. There was last time we agreed to start some discussion at the very mailing list, and then we are going to agree on what to do them, and nothing happened. So if you want to get it forward, you should start the discussion.
Okay.
All right. So the working group status. We have an implicit IEV. It's already publication request. It has been there for some time. I have no idea when it's going to be going forward. Hopefully soon. I think the AD said that he has some other issues, and he now has a couple of draft in front of this IPSECME draft, and then perhaps a couple of weeks or so. So I don't know. And the same is the post-quantum preset keys. So hopefully they get an IETF last call. And because we realize that it's not our fault, we actually mark them as done, even if we are not the IETF last call done already for them, because we have submitted them to ISG. So, all right.
Chris Wood from Apple. I just was asked to come here and comment that we are shipping a version of the implicit IV draft in iOS 13. So perhaps that will help move it along.
All right. So then we have a working process in this IPv4 and IPv6 coexistent status notification draft, and I think it should be ready for working group last call. I think we are going to be putting the working group last call out immediately after or during this meeting. Or during this meeting. You can click. All right. So and let's see. So here are some milestones. So we already marked those implicit IV and QR IQ version 2 as done, even if the IETF last call wasn't done, because it's already given to the AD and they will then go forward. But we are a little bit behind on other things, as you can see. And I think about should we actually we are trying to get these at least internal address failure indications as fast as possible through, and also the GDOI. I don't know about the others how. There should be. Hasn't been anything happening really in the ESP constraint networks, and there hasn't been happening anything in the signature algorithm negotiation. I don't know if we even have a draft for that. I don't think so. We don't. And the author of who was supposed to write it is just remembering suddenly that was the thing. Post-quantum cryptography document is probably actually going forward, even if it's actually the last one that we are supposed to be working on. And the labeled security label stuff. Let's see what happens with that. And then I think we have some announcement if you can now do that. So.
Stanislav Smishlev. So we have an ongoing process of PEG selection protocol in Safer-G. I think most of you know about this, and we have two difficult questions that we need to consider. It's integration in a couple of protocols in IETF and IntelliS handshake. So there will be a call for experts to have some independent reviews for integration of each candidate PEGs into IPSEC and into TLS. So we'd be happy if people in IPSEC working group would be able to find some time and to make reviews of nominated protocols regarding the IPSEC. I know that Valery maybe said that with IPSEC there are less problems with TLS if to think about integration of PEGs. But in any case, expert reviews from guys in IPSEC working group will be really desired for Safer-G to make the recommendations for 1 or 2 PEGs or 0 PEGs. So if you are able to come to Safer-G session on Thursday, please come and maybe respond to the call for experts, or otherwise just come to me or Alexei Melnikov or Kenny Patterson or Nick Sullivan and say that you are ready to do some kind of work. Thank you very much.
Valery Smyslov, LS Plus, and I just want to remind all of you that you probably know that there is a framework for integration PEG, and as I remember correctly, it's RFC 6467, not widely used, but at least it exists for IETF, and so probably it's time to push it, to move it forward. Currently, it's an experimental RFC. I'm seeing it was written by Terra, I think.
Stanislav Smyslov again. So, of course, if the ideas of experts from the viewpoint of IPSEC will be that all PEGs are good because there is a framework, it will be okay. But I believe that there will be a lot of issues and a lot of preferences of, for example, balanced PEGs in contrast to augmented PEGs. So I think that some issues will occur. So please try to find some time for it. Thank you.
All right, so let's go then to the first, which is the intermediate exchange for an IPSEC 2. This one. Here's the.
Hello again. It's update on intermediate exchange. And it's just first slide overview. If you forget what it is about, so it's an exchange that takes place between ICSNet and ICOS, and its main purpose is to allow IC to exchange some data, probably light data, before the ICOS take place, and take advantage of using most likely fragmentation. Not necessarily, but it was the main goal, the main purpose. And from previous version, what is changed? First, the exchange is once again renamed, this time to IC Intermediate. I think everyone is more or less happy with it. We don't need another round. Please bring it to the list. Well, I've added some consideration for integration with resumption, that it is not resumed. There's no point resuming this exchange because it is used mostly between ICSNet and IOS, and after you resume, it's no point to have it. But anyway, it can be renegotiated. Well,
Paul Wouters, to be fair, the IC intermediate is for unknown things in the future that might be big. So whether or not it's needed is not something you can say right now.
yes, but you can renegotiate it by doing assumption. So if both sides think that it is, they will use it for some other purposes while doing resumption, IKC resumption, they both will send intermediate to say support it and they can use it. For example, between IKC resume and ICOS in some other places.
Oh, I see. Okay, I understand. Thanks.
So I just want to say that it is not stored in the resumption ticket, whether they support it or not, whether it is needed or not. So next. And a few words about authentication of IC intermediate exchange. It's a complex topic. It has been changed a few times, and this is just an overview how it is done currently. And about a week ago, I had a conversation with one of implementers of IC intermediate who is currently implementing this exchange, and he complains that there are some issues with performing authentication of IC intermediate because it's very unusual. And first, he complains that it is not this is just description of how it is done currently. So for the purpose of authentication, the internal content of IC intermediate message before encryption is fit into PRF, and this PRF will later feed into ICO's calculation. And this scheme allows to IC intermediate to be fully compliant with RFC 7383. It allows resending fragmented packet when you receive no reply from unfragmented packets. So the content, the unencrypted content will be the same. So in this case, ICOs won't break when you first send unfragmented packet and then fragmented. So it's the reason why the scheme was selected. And currently, the input includes if you send a fragmented IC packet, you should reconstruct as if it is sent unfragmented for the headers to have the headers, IC header and encryption payload header have the same values as if it is sent unfragmented. And the problem is that as this guy told me, that it is very inconvenient for some implementation, highly modal implementation, because it's the point that they compute PRF. They don't know the size of IV, ICV, the size of padding, because it is in the different models that all these values are known. And another issue that has been discovered by our conversation is that if peers select a different policy for padding, then the receiver may run into a situation when the authentication will fail, even if the message isn't tampered with. So the solution that I have in mind, it is not yet published, it is in my local editor copy, is to get rid of all this crypto length stuff, length of IV, length of ICV, length of pad length, subtract them from, remove them from the length field in the IC header and encrypted payload header. So that the length that will be, the length of the data that will be fed in the PRF will be exactly that the data that will be fed in the PRF and nothing more. So, well, I'm going to publish that submission windows is now open. I'm going to publish the draft today, tomorrow. I don't know when I have time to do it. Please review it. And I don't think it's a big change. It makes things clearer for authentication. It removes this concern. At least it makes easier for highly modular implementation to do authentication of IC intermediate. I proposed this scheme to this guy, and he said that he can live with it. It will ease his life substantially. So, after I publish its draft, we will discuss. I think we can discuss it on the list. But otherwise, I think that the draft is more or less stable, and there are at least, I think now 3 implementations. It's mine implementations, Tobias, and the guys that is currently from one of the major vendors that is currently implementing it. So that's all.
Any comments, questions? So you are now going to make a new version of that draft with the, or do you actually first propose it to set a description of the list and before you start making changes to draft? Which are your plan?
I can just publish a draft and describe the changes.
Okay. Yeah. And how quickly are you going to do that?
Okay.
How quickly? When are you going to do that?
Actually, the text is ready. I need to review it. It's probably take me a day or two. Just.
So very soon we should be getting new versions.
Yeah, even before IETF, before the meeting ends. Not IETF105.
All right. If that's all, then we go to the next one, which is Paul.
Okay, so last time we had talked about the problem of the security label as we had it at the time. It was we combined it with the v4 or v6 address range into a specific selector, and I managed to convince you all that that wasn't the best way. So basically went back to the previous version of the format. So I put that in here. So this is basically what it is. It's just an opaque blob. It has a length, and that's it. So the changes I made in the last revision, I cut out a lot of writing we did about explaining how traffic selectors work, and expect you to just read RFC 7296. We split. We split the parts where because we're updating the core IETF2 RFC on what to do with traffic selectors. So I wanted to make it much more clear that this is about updating the traffic selector handling in general, and this is the update for the specific security label traffic selector. And then I made some minor changes. Allow multiple security labels just in case there's some other security system that would allow that. Be explicit in not allowing zero length. Clarifying the handling of multiple of one TS comment. Oh yeah. So make sure like it could be that that 2 security labels are allowed and that the other end can choose. I don't know what security systems people are going to use this with, so I wanted to make sure that was obvious. And then because there are now multiple types of traffic selectors, I clarified that you must at least pick an IPv4 address range or IPv6 address range, because the core RFC didn't say that, because that was the only ones you could pick. And then I made some editing errors, and there's still some cruft that I need to remove. And that is basically it, I think. So any questions?
Valery Smyslov for this plus. Paul, I've read your draft very quickly, but I am very much concerned that you have changed the rules, the basic IETF rules for narrowing traffic selectors, because if I get you right, it is no more possible to negotiate a list of intervals, IP intervals. So you, from how I read your draft, you require that responder select exactly one traffic selector substructure of type IP4, IPv6, and not multiple of it. Do I get it right? Not?
Yeah, but that's in a TSR you don't have both, right?
No. I mean that currently I in the charter can propose a list of TS substructure, and responder can accept the list. So you'll have not a single subnet, for example, but a list of subnets that are covered by one IPsec SA. And if I get your draft, frankly, I read it very quickly, you no more support this feature because you require that among the list of, for example, TS type IPv4, responder must select exactly one substructure. So you can't negotiate an IPsec SA that has a disjoint list of subnets covered by a single IPsec SA that is allowed by IQ2. So is it true? If it's true, I think that it's...
So let me just repeat what I think you're saying, because I'm still not entirely sure I understand it.
Okay.
You're saying the initiator could send something with a V4 and a V6 TS type, and then...
Even V4, but several V4 types?
Yeah, so initiator can send, two subnets.
Two subnets, three subnets.
Something and 196 or something. And the responder can actually reply to subnets also.
Yeah, exactly.
Or any kind of, subset of them. But there can be multiple IPv4 subnets returned by the responder. And that's allowed in version 2. And Valerie is saying that your draft says that you only return one TS4.
Okay, that is unintentional then. Okay, yeah, I will fix that. Okay. Yeah, no, I did not mean to do that.
Okay, so thank you.
So what's your plans for this draft? Timeline?
I will immediately fix this, and this week it will go out with a new revision.
All right. And you think this should be quite ready for last call?
Yeah.
Last call?
I think so. You don't seem to think so, but you're the chair, so it's up to you.
I was just going to make sure you are really sure about that. All right. So the next one we have then is the group key management. All right. Yeah. Just sorry. Yes.
So, hello again. Basically, it's just a disclaimer. Basically, it's this almost the same presentation as Brian did a few IETFs ago. We just updated it a little bit. So the topic is quite old and well beaten. So it's the idea is to have an ability for IPsec to protect multicast traffic. So there is a long history of, quite long history of this activity in IETF, started in 2001, till 2011. It was a MSEC working group that produced some documents. And all these documents, the problem with all these documents, the current problem is that the key management is based on IQ1 that is already deprecated. Some people will want to kill it absolutely, like Paul, to have a graveyard for it. So, we want to define a key management protocol for multicast based on IQ2 as the current key management protocol for unicast. So multicast application, well, it's just, I think you know everything what is written about, just to remind that there is at least one sender and multiple receivers. And the packets are routed while multicast routing, so that each receiver receives exactly the one copy of the IP packet, and you don't need to have a lot of all this protected by a single IPsec SA. And this requires peers of the group to share the same keys. So the keys are not negotiated, but distributed by a central group control key server who distribute keys to all group members using either multicast or unicast security association. So there are two main phases of the GIQ2. First phase is registration. When group member want to join a group, he starts doing with IKSA init. It's a classical IKSA init, followed by a new exchange that's called GSA auth. And in GSA auth, he indicates which group he's going to join. And if he's allowed, group controller key server sends back a keys for decrypting, SPIs and the keys needed for decrypting these assays that protect this group. So, and it's an initial registration. Subsequent registrations can be done more easily via one round-trip exchange, GSA registration, if group member want to join more than one group. And the other important part of this architecture is RKey protocol. There are two different type of RKeys that are supported. First is multicast RKey, where RKey is done where the same, not the same, but always multicast messages. It's something like IQ2 multicast assay. So it is like IQ2 assay, but distributed over multicast. It is one direction from group controller to key server. As the other way of rekeying is just where unicast, that initial unicast assay that group member created when he registered to the group. If this assay is kept, it can be used to periodically change keys for small groups, of course.
Quick question, if I can. We'll go back a slide.
Yeah, sure.
Is the multicast rekey actually signed by the initiator?
It is only group, it is initiated, but group controller, key server.
Yeah, if it's not signed, then any of the responders could.
It is signed. It is signed. You can see auth payload, and auth payload is.
That is a signature payload.
Yeah. Yes. And so it is. It can be. There are. If you read the draft, there are two possibilities. You can omit this auth payload. In this case, it will indirectly authenticated by providing by having the ability to decrypt it and take and verify ICV. But of course, it means that it is a shared key authenticated, so there is no origin authentication. Yes, it's for small, very trusted groups, and the more proper authentication is to include this auth payload. It is computed using signature, digital signature, with a public key that in initial exchange, group controller server will distribute and say, this is my public key. I will sign my messages with private key corresponding to this public key. So, a new payloads are added to IQ2 as GSA payloads that contains a policy. So it's algorithm that will be protect multicast assay, and it's traffic encryption, a policy for traffic encryption, for key encryption, and some other policy is not related to traffic encryption, key encryption. It's just for some very generic things that can be also distributed to group members. And the other new payload is key payload that contain key distributing payload that contains keys for traffic encryption keys, key encryption keys, LKH, it's a logical key hierarchy. It's very interesting. It's quite interesting idea when you have, I won't spend my time, a lot of time. It's an idea when you can actually change a key so that everybody got a new key except for the users that you want to drop from the group via multicast, via logical keys. Well, and sender ID, and for it is some prefix for counter-based algorithm, so that if there are multiple senders, their counters don't overlap, because otherwise it's in counter mode encryption, it's a disaster if they overlap. So each sender receives its own prefix for counter, for forming a nonce for counter algorithm. So some payloads are reused from IQ2 with slightly different meaning. It's IDG payload that indicates a group that its member is going to join, and well, SRG. Well, actually, IDG is a payload that is similar. I'm mistaken. It is similar to ID, but with a restricted set of ID types. And SRG payload is similar to SA payload, but it indicates which algorithm group member supports, so that a group controller key server can select algorithm properties for all members of the group, so that all can. He ensures that all can decrypt traffic. Delete payload is also has a slightly changed semantics, because it allows to delete the whole multicast SA. Well, there are also a few new notifications compared to IQ2. It's invalid group ID. Authorization failed when group member is not authorized to join the group. Registration failed is for any other reason registration cannot happen. And status notifies sender that is sent by group member when it indicates that he is going to send traffic. Because generally senders must be treated differently from receivers, because senders must receive sender ID for counter-based algorithm. So the group controller key server must pay attention for those who are going to send. So the draft is live for a very long time, very long time, and none of original authors currently. I am on authors list. Authors have been changing a long time. And there are few implementations, very few. One full implementation, but the old version of the draft, not the current version. And a couple of partial implementations, including minimal IQ2, GIQ2. Well, recently, the last version of the draft received quite a lot of changes. So before, the evolution was quite slow. And recently, we have a large step forward. So we think, as authors, we think that the draft can be considered as a starting point for IPSECME Chapter item. So we ask for adoption, for review, and for adoption of the draft. So, thank you.
All right, so any comments on this? This has been ongoing for a long time, and there's actually, some people who want to get this done. One of the users for this would probably be the, IEEE 15.9 maintenance or revision that is starting now, because there is need to distribute broadcast and multicast keys inside the IKC, inside the IKE. So one of the things actually I was thinking about using this for that also. So, any comments? I think the draft is. Do you think the draft is ready for last call or for adoption?
For adoption.
For adoption.
For adoption.
Yeah.
Not for last call.
Yeah. All right. So I think we're doing that.
How many in the room have read the draft? By show of hands. 5, maybe.
Michael Richardson here. So I scanned it through and I remember reading part of it well. I was a little bit surprised because I was trying to figure out why the document has the name C.Y. Young, but that's not one of the authors. And then I discovered the list of authors at the end with their addresses, which is a bit unusual to have their full addresses as contributors. just as a surprise, but I understand what's happened. But given that those 4 people who are critical to the creation of the document don't seem to be participating right now, and I think that the München group were at IETF 10, what is the last one? 4 in Prague, right? They're from the University of München. Are they still active at this point? What I'm concerned about is that these people, none of us are doing multicast, and while we may think it's very interesting and we can criticize the format of your auth payload or something, we may not really understand things. I'm really concerned about ability to get the multicast side of the review done right in this working group, because I think you have enough IKV2 expertise to make up for any of our lacking, but I'm not sure that we have enough multicast to help. Does that make sense, my question?
Yeah, so the question really is that how much of the multicast stuff is changed since since there were still authors out there knew about multicast in there.
And how are you going to get those implementations interoperating and doing things? That's what I'm kind of concerned that this is almost an academic exercise.
Yeah, my understanding is that the basic stuff is still same. It hasn't been changed. The change is really changing, IC version 1 format of the payloads to IC version 2.
I get that, but I'm still concerned that those people those people who are going to use it are not really involved. That's what I'm concerned. But maybe there's a whole bunch of IEEE 15.9 or whatever people that will review it for us. I don't know. That's what I'm concerned.
You mean me?
Yeah, I know. That's what I know. I'm hoping there's like 100 people behind you, right?
No. Let's put it this way. Last meeting, I was the first 15 minutes, I was the only person in the room.
I know.
Because I was chairing it. And then there came two other people looking for me, but not for that reason.
I just want to remind that Brian, who is still a co-author, was a closing chair for GDUI MSEC working group, so I think he has some experience in multicast because he was chairing that group when it was acting for IQ1. So I hope there are some people who understand the topic.
All right, so I think we can still hit our charter, so I think we should be doing the working group adoption call for that anyway and start and see what goes on. Okay. So the next presentation is going to be that was the work items really, but it's where we have a clear charter already, and then we start going to these other presentations which are in a process of perhaps being in the charter items, I think. So let's start with the post-quantum key exchange. Valerie again. We always put you in every other spot, so you have to jump up and down. You can't keep hogging this mic for the whole time.
So, hello once more. It's an update for quantum-resistant IQ2. If you forget what it is all about, it's just an overview. So we are all very much concerned about quantum computers. And we think that hybrid key exchange is the right way to go that will combine classical ECDH with some post-quantum methods that are not very trusted yet. So we combine several of them from with different properties. So to be sure that the combined key exchange is secure enough. And the protocol take advantage of using IK-intermediate exchange. And in this IK-intermediate exchange, an additional key exchanges take place that are presumed to be quantum resistant, but it is not a requirement, it's just a framework. You can combine, for example, several classical key exchanges if you want to for some, I don't know, policy reasons. So it is not strictly linked to post-quantum. Well, but anyway, after each exchange, I could say keys are updated so that new shared secret generated from this key exchange is steered into the SKI, and all other keys. So the changes from previous version, as I already said, with the clarifications that this is framework, it can be used not only with post-quantum key exchange method, but it can be used regardless of the type of key exchange methods, whether they are classical, post-quantum one, quantum-safe ones. So small clarification of using nonsense in OSPO load calculation. So only nonsense from IKC NITA are used, and not the nonsense that are exchanged in IK-intermediate exchanges. And there was a lot of text, a lot of clarification added for Ricky collision. And because Ricky collision is a complex topic, and it is very well covered in IQ2. And since with additional key exchanges, we require information exchange followed by create-child assay exchange to complete the rekey, to complete creating take child assay. The collision are handled slightly differently. So I will talk about it lately. Take some attention. So key derivation also is defined, because in previous version it wasn't defined for create child assay case, and ionic consideration are updated. We're just asked to rename Diffie-Hellman group to key exchange method registry. Well, just a reminder, what about create child assay? Additional key exchanges are performed in a series of informational exchanges that are followed create child assay exchange. And new notification allows to responder to link these information exchanges to previous create child assay exchange. And negotiation is the same in IKSA need. And new assay is created only when the last information exchange is complete. So all the exchanges are completed, and we can compute the keys. So it is an example how it takes place. So what about rekey collisions? IQ2 says that if two peers start rekey process simultaneously, then rekey collision take place. That will result in creating two assays. And IQ2 handles this situation by determining who is winner, who is loser. The loser by comparing nonsense, and the loser has to delete the extra assay that he created. And it is also another situation is possible when, due to packet loss, only one side notice the collision, and it is handled a little bit differently in IQ2. Well, so with quantum safe key exchange, what's changed comparing to IQ2? A collision must be resolved in a create child assay. So before any information, not before, in some cases it's impossible, but in any way, information exchanges must not be affected. No determining who is winner, who is loser during information exchange must not take place. Create child assay must determine who is the winner, who is loser. And since assay is created only when the last information exchange is finished, so once create child assay is finished, no assay, no extra assay is created yet. So the loser just stops rekeying process, but not initiating next information exchange. This is a difference. And well, error handling. In situation when due to packet loss, only one side notice a collision, the other side will try to retransmit packets, but the side that notices the collision will send temporary failed notification. It is an indication for that side that didn't know the collision that it must stop rekey process. That collision took place. And it is also possible that the responder lost its state before the next information exchange come due to, I don't know, network delay and something like this. And so if responder receives an information exchange with additional key exchange notification containing data that doesn't correspond to any stage, he responds with state not found. State not found, it's a non-fatal notify, new notification that tells initiator that the key process failed. Just either try it again or I don't know. There is something wrong. And how keys are created in create child essay. It is differently. They are created. New keys are created differently from initial IETF with IETF intermediate. So we just steer all these shared keys with corresponding nonsense to PRF and get either SKCT or KeyMat, depending on whether you rekey IETF or rekey or create child essay. So one outstanding issue, and we discuss it with Scott, and do we need nonsense, fresh nonsense in every IETF intermediate, or we can reuse the nonsense from IETF need? So currently every IETF intermediate or informational, if we talk about create child essay case, has its own pair of nonsense. Well, we're not sure that it is needed from cryptography point of view. Probably we should ask CFRG. Well, or probably Scott will comment about it.
If you want to comment, I don't know of any cryptographical reason at all. They always have to be fresh. It was only for liveness, and we that's already for proving liveness, and that's already there.
Well,
Can you go back a couple of slides? I think it's the one that has the create child and the informational one.
This?
Still more. The one more, I think, is that one. So is there a reason why you're actually using informational exchanges for the rest of the create child stuff?
Because we need to make an additional key exchanges, and we want to have the same properties as for initial exchanges, where every key exchange is handled by every key exchange method. It's handled by a single IETF exchange, and in that case it is IETF intermediate. In this case it is information exchange. We just reuse information exchange for these purposes, just not reinvent another IETF intermediate that it's not intermediate, but for this purpose only.
Yeah, I was thinking about it. I would because we to make this work, we have to add new, like intermediate is already added there. So I was thinking about it. We could also add, second, new exchange type there, just to keep the informational to be, informational messages, because this is not really part of the informational.
Informational is some, for all purposes, as far as I understand, you can do anything with it currently.
Yes, you can, but it would be nice to have some kind of separation of architecture, that you do informational with this kind of information stuff, and that you would have create child to do that. But this would be, but it's just a minor point.
Well, we can define a new exchange, but I don't know whether it is needed. Well, of course, if we define new exchange, it will be clearer from purist point of view, but from practical point of view, information exchange in this case is very, very easy distinguishable from any other information exchange. Its content is quite unique, so it's just an exchange type raised.
Okay. Paul Wouters. Yeah, I also agree that using a different exchange would be nicer for the state machine, and like it doesn't overload all the informational payload handling and avoids problems about what do you do if you find a delete payload and this new payload and get bugs in there. And since you renamed the intermediate exchange to IETF intermediate, you now have one that you can call SA intermediate. And you really see it.
Okay. Hi, I'm channeling Tobias Heider, and +1 on what Tara is saying. Exchange IDs are cheap, and the other thing is Reusing exchanges makes parsing hard and makes it more error prone, which should be avoided.
Okay, we'll consider it. So, thank you. Questions, comments, and actually, we discussed with the authors, all the authors team. We asked for adoption. It's our opinion that the draft is ready for adoption, and I just want to remind that there is a topic, an item in IPSECME Charter about handling quantum safe, adding quantum safety to IQ2. So I think that the draft can be used as a starting point, as a good starting point, I hope.
Yeah, so
My-
I think I need to move it to the upper layer, to the work items, not the other items.
Yeah, Michael Richardson here. So I'm for adoption. That's great. And I just want to make sure I understand. So this basically creates a framework in which
Yes,
people
exactly.
who have quantum key exchange can now plug their specific thing in.
Yeah.
I'm a little bit concerned about the chaining of methods together. I think it's going to be really complicated to implement. And so I actually kind of want to suggest that, I don't know how to say that, after we have adopted this, that we should write another document that creates two, maybe even has to allocate IANA numbers, two new exchanges, which we could implement as ECDH with a lot of padding or something, such that people could actually see if they have interoperation with some pretend exchanges. So to see if to see if their state machine that processes these extended things works correctly and interoperates with the other guy's state machine that works properly, at which point we'll know that this document is correct. Do you see what I'm trying to say? Is we don't really have a way to test and validate this document unless some people go and either already have done the quantum exchanges that they want to do and get it all out, or they use group 18 because it's so huge and it requires some things. That's exactly what I'm trying to say. Use group 18, okay, but maybe give it another number, which is, you know, the other group, okay, just so that it's something else. But I don't know, something like that. That's what my suggestion is. That's somehow, I think as a group we need to validate that the state machine changes you're proposing are well enough explained that we can get interoperability later on.
Well, I just want to add that there is at least one implementation of this draft currently, and at least one, I don't know whether full or not, Tobias Heider has implemented, and myself has implemented the full draft. So it is, and I'd like to say that it is a public server that is open for anyone if somebody
So
wants
you have
to.
online testing, great.
Okay.
That sounds good, okay.
So if somebody wants, just write me, I will.
Yeah, Ben Kadek, just noting, I'm pretty sure, I'd have to check, but I'm pretty sure that there are early allocations available for temporary usage for large-scale experiments for code points if we need them.
Terokivinen. Oh, we can also add, you know, there have been some requests on adding, you know, 12,000 bit and 60,000 bit RSA groups. Those would be also new numbers and even bigger. Bigger is better.
Hi, so channeling Tobias again. We at LMU Munich are actually working on a formal verification model to make sure the state machine is working.
Okay.
So again, how many people have read this draft? 9. Any concerns at this point with moving this towards working group adoption? Okay.
The next one is the IP traffic flow security.
X marks the spot. Hi, Christian Hops, and this is a presentation of the update that we published to the IPTFS draft. Oh. So just a reminder, why are we doing this? Maybe didn't make this as clear as we can here last time. Basically, the current solution is to just pad out ESP, so you get a 1-to-1 packet ratio for it. Well, the current solution to hiding your packet sizes is to pad it out, and the end result is not deployable. We've had people who've tried to do this, and it's not deployable for them. Primary reason being, if you see from the graph, the left side shows you're utilizing a gigabyte of bandwidth, right? But you're only getting 200 meg, and it's really not deployable for people, the efficiency. So the updates was really kind of like hardening that came due to a couple things. One, we were implementing, and two, the updates based on the things we heard back from the last IETF. And from TSV folks on the congestion control. So we added so these are the updates. I think I have a slide on basically each one of these. So we added a new IKE v2 transform type. So this is a nice way, the correct way to negotiate things on SAs, right? So basically it adds a new transform type. The 6 is the next one after ESN, and it allows you to say you want to do congestion controlled TFS, non-congestion controlled TFS, or none. And we make the suggestion that if you're doing none, just leave the TFS type out, right? But it's there to be rounded around. So this is a mistake. Anybody who's really into IKE probably is probably, I just saw it like with the earlier presentation, I'm like, oh man, I wrote SA in it. It's IKE auth or create child SA is when this transform type happens, not SA in it. Sorry about that. In the draft, it is correct. I went back and checked to make sure this was just a presentation error. So one of the things we got from the working group was that there might be devices that don't want to support fragmentation. So only, aggregation is fine because you've got a bunch of packets in one, but fragmentation is hard because you have to keep things around to reassemble. And so we add a don't fragment notify message. And I looked around, and this is basically how it's done for other things to modify how, once you select transforms, right? How do you modify or say, but with this caveat, right? And so I reused that concept. So during the IKE auth, you'll select, somebody would select, yes, I want to do TFS CC, and then send a notification message back saying, don't fragment. A pretty clean way to do that.
But they can still put multiple packets in one.
Yeah. So aggregating is not a costly thing, right? I mean, you get a packet and you break it up, right? You're not waiting around or queuing up or anything. So we also updated the congestion control. So we were doing some different thing with IKE, and it was just causing a lot of problems out of band. So we just moved the congestion control information in band. So you can see the boldface here. So the old header was just the bits reserved in block offset, followed by the packet data. We added some optional congestion control information, and that is here. So some of the feedback I got was from David Black about, we needed to be a little bit less hand wavy in our congestion control stuff. So I went through and basically made sure that we can implement the recommended TCP friendly congestion control mechanism. And this is the data that is required to do that. So it's a round trip time is basically the time it takes to send and receive back. The delay is the amount of time that it's transiting the control plane at the endpoint. So we know the sender will send out the sequence number. It gets back the the last sequence number. It's able to calculate how long that was, and it adds a delay. And then that is the round trip time. The receiver side is calculating the loss event rate based on that. It's fairly complex, but smart people have thought about it and written drafts, and you don't really have to think about it anymore. You just have to follow the directions. So that was what I put in here, is how to follow the directions. Yeah, so loss event rate, so it's a fraction, right? Loss event rate is a fraction. It actually, I think, right, so it goes into that formula there. That was a lot prettier earlier. Right. That it really was pretty. I don't know what happened to it. It's almost unreadable now. It's 1 over that whole thing, right? And P is your loss event rate, and like a capital R is your round trip time. And this is basically, so that it spits out packets per second to send. So what the addition to the draft basically was to go through and align the language with the existing RFCs that are there. And then we added an appendix which specifically says, here's the data that's in the congestion control packet header, plug it into this formula, and you get packets per second out that you should be sending. So that's the summary of the changes. We basically, we updated the work based on the working group comments. The congestion control don't fragment, and then on implementation experience, we moved to the transform type, and also the algorithm. We added the guidance because we thought it would be important to let everybody know how to do it. And so we're wondering if we could do working group adoption.
David Black. So Christian and co-author asked me to take a real quick look at the congestion control stuff in here from are they digging in the right place perspective? Simple one-word answer, yes. There's two things going on. One is Christian just told you about TFRC for the congestion control stuff. And the other is that they're planning to reduce the previous case for non-congestion controlled stuff by referencing the MPLS over UDP RFC, which survived trial by fire. So we know that the discussion in there of how to deal with traffic that does not respond to congestion is reasonably good. Word to the chairs, if this draft is adopted, this is exactly the sort of draft for which requesting an early TSV area review would be a good idea.
So the first thing is that we can't adopt it because this is not in the charter. So we have to recharter first. So that's in for the 80s, not for us to decide.
Yeah, but just sort of heads up. This mean the authors did a real good thing by asking a transfer expert take a look. And if it goes forward, you probably ought to ask for an early transport area review well before working group last call, because there's a boatload of details in this text that a really good transport reviewer will help the authors get right.
Valery Smyslov for this plus. First of all, thank you for don't fragment, because it was me who complained about it. And then just a comment. The purpose of your document is to fill as much data to ESP packet as possible.
No. I want to clarify that, because that was something that was misunderstood last time, right? We're not trying to make it efficient. Right, we're trying to. It's traffic flow confidentiality, right? I mean, the purpose is to actually hide the data size, And if you remember from last time, there was a Usenix 2017 presentation where they used an IPSEC tunnel and they put Netflix data over it, right? And somebody was snooping on that and telling them what movie they were watching.
Yes,
right?
I understand, but for the fixed packet size, you want to put as many.
Oh yes. Yeah, we want to
optimize as possible.
Yeah.
Well, and that's why my question, or probably comment, did you consider to reduce the size of reserved field, because it looks like it's quite a lot of reserved, at least certain bits that are unused. For small packets, it will just you lose noticeable percentage.
We considered we thought about ways to do this where you could eliminate the header altogether. Yeah, we're looking at generally, the implementation will probably either be set at the maximum MTU, or it will be path MTU discovered. So we'll generally be working, with the largest MTU. So it is, you're talking about 12,
Well, I'm
14
talking,
bits.
I'm
It's
talking about
something, but-
reserved bits in data blocks. It's 13 reserved bits that I unused in
Yeah.
your definition. So it's too many, probably 8 bits for flex is enough.
I mean, did we get the nice alignment,
I think it doesn't matter anyway.
Okay.
You just put as much as possible. So
Yeah,
alignment
okay.
probably is not. Okay, thank you.
Paul Wouters. So you're using a traffic selector to request this, right?
No, it's a transform type, right? So not a traffic selector.
Oh, it's a transform type.
Yeah, so basically it'll be, your auth, your key, whether you do ESN, your Diffie-Hellman, and then we're adding in whether you want to do TFS or not.
Okay. I'm trying to think if it's not clearer or easier as a traffic selector now.
Well, because we operate in TFS only mode on the SA, it doesn't, it literally is talking whether this SA is TFS or not. That made sense sort of at that level then.
So a little bit more same, and you do a transport or tunnel mode.
It's a new kind of tunnel.
Yeah.
Not a new kind of traffic.
Okay, fair enough.
So because this is not on our charter, we need to know if there's actually. So do people actually think that they understand what this problem is and what we're which is this? How many people actually think that they know that what this is for? Okay, there seems to be lots of people who know what it is about. And do you think that it's actually something that we should solve here in IETF? And in this working group? All right, so I think that then we have to probably go and ask for the ADs and think about if they can actually reach out and add this, because I think there seems to be clear interest. And I guess there is also people who would be willing to review and perhaps implement that and check on this. Yes, okay, good. All right.
Not only is this something that we should do, I mean, this is something that IKV2 is supposed to have done from the start. I mean, we had this, I think it was a notification that traffic flow confidentiality is or isn't supported. And yeah, I mean, we're supposedly been doing it for over 10 years, so it's time that we actually did it.
So I have one
We don't have pre-charter.
So I have one question about you were measuring this thing, but was that the measurement done with the real traffic, or was it because one of the things I have to think about it quite often, especially the other direction is going to be very, very small pockets, but you need to get them quite quickly because otherwise if you don't get X, you don't set the big packets.
Right. Oh, yeah. So it was just kind of hidden so I didn't actually bring up like 2 Docker containers and run it, but what I did do to make it realistic, right, is it's IMIX, right? So this is using a standard firewall IMIX, which is 7. So the distribution is 741, and the packet sizes for that distribution are 40/64, 576, and 1500, right? And I was very fair to ESP because ESP with padding is really, really horrible with 1500. It's half. Right. And I was like, but really it's not 1500. We're talking about the largest path MTU. So I actually went to 1460 for this graph to be fair to ESP, because I knew it would adjust. But yeah.
But I also assume that you have to wait you can't wait for, packets to be accumulated forever because you want to send X,
Yeah. Well, so, I mean, there's a big latency problem as well, right? Because you're sending all these bytes. And so instead of going 64, 64, 64, you're going 64 plus a lot of padding, and 64 plus a lot of padding. So that's the other reason it doesn't work with TCP well.
Right. So, okay, so we will check out whether we talk to the ADs and see what's going to happen.
Okay, thank you.
Thanks. And then we have the last presentation. Optional SA and TS payloads in chart extension.
Hello everyone, I'm Wei Pan from Huawei. Today I want to introduce our a little bit optimization for rekeying IKE essay or child essay. First, you can see the original rekeying message exchange like that. If the configuration like the cryptographic suites or the traffic selectors doesn't change, but the rekeying will, at rekeying, the SA and the TS payloads will also be transmitted. And but even if the even though these are transmitted, but the selected cryptographic suites or TS will not change when doing the rekeying. So we think this can be optimized, and because the IKE SA and child essays are rekeying, this rekeying happened periodically. So for the constrained device like IoT devices, processing the SA and TS payloads in such case is a periodically burden that can be augmented. In 5G networks, there are more than many devices, like more than 10,000, and these devices may have only one gateway to establish IKE or an IPsec kernels. So the bandwidth that the SA and TS payloads occupied can be a huge burden for the gateway in such case. So our optimization solutions is very easy. When doing the rekeying IKE SA, we do not need to transmit the SA payloads. We just need to send our new notification payload with a new SPI. And for rekeying child essays, it's similar. We don't need to transmit SA and TS payloads. We just transmit our new payload notification payload with the SPI. First, when you need to do such optimization, you need to we add a new notification to indicate the support for this functionality. We call it a minimal rekey supported notification, and it will be sent at IKE off message exchange. The initiator send this included, and if the responder also support this function, it can reply with this notification. And you can see the payload format as below. It contains no date. It's very simple. About rekeying IKE essays, in the draft we divided into three cases, but the most common situation is the first one is that no change of cryptographic suites in the initiator and the responder. So the initiator can send, we call it SA unchanged payload, and the responder will reply with the responder SPI in the SA unchanged payload. About the left two cases, it may not so common, especially for the second. If the initiator's CS changed, it may immediately send the rekeying message. And if it's a real change, that means the previously negotiated CS is not existed. So the responder may not have the chance to choose that one. So the number two case may be not so real. But for the third case, that the responder changed, but the initiator doesn't change. So the initiator will also still send the SA unchanged, and the responder will respond with no proposal chosen to indicate that the previous negotiated CS is not allowed. And then the original rekeying can be conducted again.
If I were to make a suggestion, case number 2 sounds both rare and it might be a little more difficult to handle. You may just want to forbid that and just only go with either 1 or 3.
Yeah, I agree with you. Maybe I will change it later. For the SA unchanged payload format, it's also very easy. It only contains our SPI value. Anything?
I have a question, but I want you to finish your slides first.
Okay. Okay. About rekeying the child essays, it's similar with that one, but the case is that no change of graphic suites and the ACL or the traffic information. So the payload is as the same, but the SPI is 4 bytes. You can see the format we listed here is a comparison. The left is previous, the original one, and the right is after we optimize it. And it's just a show. And about the optimization effect, we calculated the bytes before and after optimization. You can see that about when doing the child essays, the reduced bytes percentage is quite valuable, I think. If more than 1 CS are contained in the SA payloads, then the reduced bytes will increase slightly. Also, if you don't send the SA payloads and you just send this, the computation will be easier, so the time will be saved. About future plan, we welcome more comments and reviews, and we are looking for working group adoption. Yeah.
Michael Richardson, just a question for implementers in the room. When people configure new policies on responders, do you actually enforce them? How do you actually enforce them on existing SAs? I'm actually asking about the case 3, that you kill them all and you make them initialize everything. Anybody else do something different?
Yeah, we will basically.
Mike, use the microphone.
We will actually implement the new policy on a rekey.
So on a rekey of the child essay? Yes. Okay, so you would actually face this case 3. What I was hypothesizing is that everyone did what UF does, either just lets them go until they go and then goes, oops, you're dead, try over. And for remote access scenarios, they go down and up so often, that's probably easy. Or if it's a site-to-site, with the new policy, you initiate immediately with the new policy and you kill what was there. And so my hypothesis is that number 3 is almost never encountered. That's my hypothesis, right? But it sounds like it's not true.
Yavner, so yeah, supposing we have tunnels that are being used and they're using single DES, and we suddenly decided to change the policy to do ASGCM 256, and no, I can't believe we're waiting an hour until the old DES SA is going to expire. It does make some sense when both sides are not simultaneously configured. So maybe I change the policy of one and it's doing a rekey while the other is not yet changed. So this could happen, but yeah, it's not really very realistic. I agree.
Paul Wouters. So I really like this draft, and when I started reading it, and I went back to the IETF2 RFC, there's specific text in there in the core RFC that says, during rekeying, if you see the traffic selectors, really make sure that they're the same, because we don't want to negotiate slightly differently narrow down traffic selectors and end up with a different tunnel after rekeying. And when you read it, you go like, why did we even ever allow that to happen? We should have just not sent a traffic selector so that people couldn't make that mistake. And this is exactly what you're doing. So I think this is a great idea, and we should have done this like in 2004.
Valery Smyslov for this plus. I think this is interesting idea. It is not, from my opinion, it is not very useful for ICSA. Why? Because, well, it depends on the implementation, but for a key, initiator can send only those transforms that were accepted, that were used in previous SA, if its policy isn't changed. So the win that you have with notification, with don't sending any transform at all, is negligible for ICSA. For IPSEC it is different. And as Paul said, IQ2 RFC requires to send traffic selectors in every key of child SA, and traffic selectors can be quite long. So if you omit traffic select, well, if you simplify your draft, get rid of many options that complicate implementations, and probably if you get rid of resending the same traffic selectors within every key, that can be quite long. The win will be, I think, the trade-off of implementation, it will be better.
Yeah, we will consider.
As a member of the group, not as a chair. So I was actually thinking about this original thing about it's actually small optimization, but it actually might be useful, and especially for the rekeying for the child essays. And yeah, I think we actually should just we can actually, if we negotiate this beforehand, we don't actually need any kind of most of the notification stuff in there. We can just leave out the if you leave out the traffic selectors, or sorry, if you have a rekey notify, the rekey essay notification there, it gives you the old SPI. We could actually just think about it and said, new SPI after that, and remote the essay and traffic selector payloads completely, because, if we are rekeying, we are using exactly the same algorithm, we are using exactly the same, traffic selectors. We just need to change the SPI and generate a new key. Of course, most of the cases, the useful thing would be also to do the, Diffie-Hellman at the same time if you want to have a PFS, but that's a separate issue. For ICSA, it gets a little bit more, and it's actually much more, let's say, you have only one ICSA usually, and we might have, thousands of IPSEC essays, and you might rekey them much more often than you do ICSA. I don't know. I don't really see, there's really no reason to, for example, rekey ICSA ever because of the traffic limits, because it takes so long time to actually be able to transmit anything, so much data that you actually need to rekey because of that. So the ICSA rekeying in mostly just, because, we want to rekey because we want to limit the, the exposure if somebody hacks into the system. So let's say, once a day or something like that. So it's a much more seldom than the IPSEC essay. So I think the IPSEC essay case is the more important one. And I think we should just, say that, okay, we do the full normal. If the policy is changed so that your traffic selectors or your, algorithms don't match anymore, it's not rekey. You create a new essay and delete the old one. If it's a rekey, meaning your algorithms and the traffic selector are same, you just rekey it by saying, we have a rekey essay, and here is an SPI, and here is a second SPI that goes the new SPI. Because I don't think we actually need anything else.
So I tried to take notes and I couldn't quite.
Sorry, Yavnir, so I have a question. When you're rekeying child essays, could you go to the slide that shows the exchange?
Sorry.
Can you go back to the slide that shows the exchange?
Show the exchange. This one?
No, the swim track diagram. Oh, never mind. How do I know which essay it is that which child essay it is that I'm rekeying?
Oh, you can refer to the Rekey SA notification. It contains the older
it contains-
SPI.
Okay, right. Sorry.
It's not just the notify, it has bulk stuff in it.
Here you can see the Ricky.
Yeah, I saw that about the new notification, but I forgot that it was also in the old one.
All right. So, as a chair, I think it actually goes under our stuff of compressing IC and IPSEC part, so we can actually put this into the charter. So this actually could be in the charter. We don't have to re-charter, which is surprising because I was assuming we have to. But then I was reading our stuff and oh yeah, we have this. We can compress and modify and make it smaller for constrained devices. So even if I actually expect that most of these devices that you are running are not constrained because you have your 5G after they're actually much more powerful than most of the other things you have. But anyway, so okay.
The networks are constrained.
Let's make the same questions again. Okay, how many people actually think that they understand that what this problem is? All right, and how many people actually think that this is something that we should solve here on IETF and in this working group? All right. Okay, and so how many people are interested in working on this and perhaps making reviewing draft and okay, and how many has already read the draft? Okay, but the same people who are interested in reviewing draft. So I think there's actually enough interest on that, but yeah. So I think we should probably think about. Tell me. So, and you think that this draft is ready for a working group adoption, or do you think we will have more changes based on what we actually have a discussion here?
Adoption.
Adoption. Sorry. Yeah. Do you think that it's ready now already?
Yeah, I think it's ready.
All right, because we are going to, of course, start making changes also after we have adopted as a working group draft. And as I said, I had a couple of ideas where we actually make it even more better or something, more constraints or something like that. And of course, the question is, how much we actually want to do optimized type? I can say Wiki is also adopting it. But yes, so I think we could actually start a working group adoption call for that one also. All right.
Yeah, that's in the next.
Yeah. Okay. And I think that was the last. So we are actually.
That's it.
Yeah.
Any other business? Any other business?
Oh,
All right.
And everybody has to sign the blue sheet.
Where are the blue sheets?
Since no one of NIST is coming up to talk about their shiny new document, I will mention there is a new revision 1 draft guide to deploying IPsec VPNs. You should read it and comment on it because you shouldn't trust like the authors who wrote this.
Well,